Okay, so volume. So volume, of course, is the internal area of an object, and so that's the amount of space that it takes up, or it could be a measure of what it can hold. So if I was buying a shed, for instance, to store my hay or whatever, I want to know how many cubic metres that's going to hold. It's a three-dimensional measurement, and it's measured, therefore, in cubic units. So your measurements, as soon as you see these powers of 3, if they hadn't told you what it was they're measuring, as soon as you see those powers of 3, you know that it's a volume that it is in fact measuring. So again, most people, if I said to you to convert something from metres to centimetres, what's burnt on the back of our brains is that there's 100 centimetres in a metre. So most people would say, well, if I'm going from metres to centimetres, the number's going to get bigger, so I'm going to times, and that would be correct. And people 9 times out of 10 just times it by 100. What you have to remember is, though, here what we're actually dealing with, and I haven't put them on here, is we're converting measures of volume, so it's to a power of 3. So when I do that timesing, I need to also times it by my normal factor, but to the power of 3. Now, 100 to the power of 3, of course, means 100 times 100 times 100, because that little power number at the top tells me how many times I'm multiplying that base by itself. Mentally, some people get tied up with this. 1 times 1 times 1 is just 1. I've ignored all those zeros, so I'd be putting all those zeros back on, which is going to give me 6 zeros. So all up, really, I'm timesing by 1,000,000. However, I don't want you to try and remember that, because people invariably mess it up. So keep your usual things in mind. So if I was going centimetres to millimetres, most of you would very happily tell me that there's 10 millimetres in a centimetre. So times it by 10 like you always would. But if it's cubic measurements you're dealing with, then your 10 needs to be raised to that power of 3. So hang on, I'm just going to take that circle off there. Okay, so that's the way I prefer you remember it, and you're less likely to make a mistake. Likewise, if I'm going backwards from millimetres to centimetres, I'd be dividing by 10 to the power of 3. And if I'm going from centimetres to metres, I'm going to divide it by 100 to the power of 3. The only thing you've got to watch is, when you're in an exam and you're reading a question, read the question first and see what they want the final answer in. So often they'll say they want you to express your answer in metres, or they might say they want your answer in litres as opposed to millilitres. We haven't done capacity yet, but when we get there, clue into those things. And sometimes it's easier to convert your initial measurements first rather than doing a final answer in, let's say centimetres cubed, and then converting that to metres cubed. It's sometimes easier just to start with all your measurements in metres if I want my final answer in metres. And again, if I was going to explain why that works by that, so if I had a cube here and I said that this cube was 1 metre by 1 metre by 1 metre, then when I said to you, well, what's the volume? You'd go 1 times 1 times 1, length times width times height, and you'd say 1 times 1 times 1 is 1 metre to the power of 3. But if I said to you to convert that to centimetres, I wouldn't just go times 100. My answer is not going to be 100 metres cubed. You know that each side would be 100 centimetres times 100 centimetres times 100 centimetres. And excuse my dog snoring in the background. So then 100 times 100 times 100 would give me that volume of 1,000,000 centimetres to the power of 3. So that's why it works. If it helps you to understand it, then you won't need to memorise it. Okay, so to find the volume of a prism, then basically if it's a rectangular prism, it's length times width times height, and most of you are fairly good with those sorts of things. For a cylinder, and for any other shape really, generally what we're finding is the area of one face and then timesing it by the length of their face. It's actually like the same with these squares. What we've implicitly done when we go length times width is that we've found the area of that roof, and then timesing it by the height of that shape then turns it into that three-dimensional sort of thing. Same with a cylinder, so that pi r squared, which is the first part of my formula, a pi r squared is just a circle. So what we've found is the lid of that cylinder, and then timesing it by the height turns it into that three-dimensional shape. And again, I haven't put time signs in there, but implicitly that is what we're doing. I prefer that you don't put time signs in because they look like X's. Okay. Now, when we come to do something like a cone, then there is no uniform face, and as I say, typically we do that. I'm going to revert backwards for a moment. If I had a shape, let's say like a loaf of bread or something, and I asked you to find the volume of the loaf of bread, then you don't have a formula for this shape, but I'd have to tell you what the surface area of one face was, and then I'd have to tell you what the width of the thing was. And so here I'd say, well, I know the face is 24 centimetres squared, and then timesing it by the width of that shape, and that would give me my total volume. And what I've done implicitly is, as I say, find one uniform shape. When I say uniform shape, what we mean is when we started to slice this object up, that face would be the same all the way through. So same with the cube or the rectangular prism. When I slice this through in this direction, those faces would be identical to that roof all the way through. And that's what we're invariably looking for when we start to find the volume of shapes. With cones, this breaks down because there is no uniform face. So what I start with here is I start by finding the area of the circle. So that's my pi r squared component of that formula. But if I was to slice this shape through, you can see that circle would get smaller and smaller as I went down. It's not uniform. So basically I do my pi r squared. I'm timesing it then by the height of that shape. And if I just did that, what I'd be finding would be the surface area of a cylinder. So to allow for the fact that this shape actually tapers, we do this divide by 3. And that basically works for any kind of tapered shape. So when we get to the pyramid, what you can see here is in that formula, it's length times width times height again. So the length of my base, the width of my base, the height of the shape. That, if I did just that, would be giving me a rectangular prism of those dimensions. But of course, we want that to actually be a pyramid and taper. And so to allow for that tapering, we've again doing this divide by 3. So, and again, pyramids can be square based, they can be rectangular based, they could be triangular based, but the process would be the same. Find the area of the base of the shape, times it by the height of the shape, but then divide by 3 any time you see tapering. A sphere is a ball. It's less obvious in its tapering, it's not coming to a point, but it's certainly that shape narrows down. So it's the same deal. Hopefully you'll recognise the first part of this formula. When we did surface area, we went 4 times pi times r squared. With a volume, it's still the 4 times pi times r. We now have a power of 3 because we're doing a volume, and power of 3 is always a volume concept. And then dividing by 3 because it's tapered. So that hopefully will help you to understand the formula. Sometimes it's written to look like the one on the bottom, so they will say 4 on 3 times pi times r squared. The two formulas are identical, so be comfortable in seeing them written either way. Okay, so let's put these to use and have a go at some of these questions. So the first one should be dead easy. It's just a nice rectangular prism, so my volume is just going to be my base times my width times my height. And for that one, you would wind up with an answer of 72 metres to the power of 3. So because I've done those 3 dimensions, it's a 3-dimensional measurement. When you come to do a triangular prism, you're first going to get the area of what we call a uniform face. So the only uniform face here is our triangle. So I'm going to get the area of a triangle, and then I'm going to be timesing it by the width of that shape. So to get the volume of this one, the triangle is a half times my base, which is 8, times my height, which is 5. That will give me that triangular face at the front of the shape here. And then I'm going to times all of that answer by 4 to make it a 3-dimensional shape. And that would give me a final answer of 80 centimetres to the power of 3. My next shape is what we call a composite shape. So we're going to be breaking this one up into a rectangle and a cube. Well, it's not entirely a cube, but 2 rectangular prisms really. And I could have divided it this way, or I could have divided it this way, and it doesn't actually make any difference, so don't get bogged down on which way you go. So if I did my first one this way, then what I'm doing first of all is finding the face of this rectangle in the front. So that would be, now first I've got to get, change colours here. First I've got to find out what these measurements are. We know they're all the same, but we're not told what they are. What you can see is that, we need to go this way actually. If I dropped these top two, they would form that 10 metres that we're told here. Because I know they're both the same, I therefore know that each of those measurements must be a 5. So all of those measurements are 5. So my first rectangle, when I come to do my volume, is going to be 10 times 5. So I've gone my base across here times this height, timesing that by 7 to turn it into my 3-dimensional cube there. Plus I've got the rectangular prism on top, and again, because I've got all these markers, and I'll just move all my highlighting for you, I can see that the measurement of that is again also going to be a 5 and a 5, and the width along here is going to be a 7, the same as the width there. So for that second shape, I'm going to have 5 times 5 as the face there, and then timesing that by 7 to get my bit there. And hopefully that will give you an answer of 525 metres to the power of 3. Okay, let's have a look at another one. So now we've got these cylinders. So here you can see what they've given you is the diameter right across. For the cylinder formula, we need just the radius, so we're looking at just this, mark halfway along, so half of 5 is 2.5. So when I come to do the volume of this cylinder, it would be pi times my radius, which is 2.5 squared. That gives me the surface area of the triangle, circle on the end, timesing that by the depth of the shape, which is the 9, my bad, I don't know where I glanced up and saw that one. So times my 9, and that will give you that surface area there. I'll leave you to throw that one into your own calculator. Okay, let's have a little look at my next one. So next one here, they have given me the radius for this one. So again, my volume would be equal to pi times my radius, which in this case is 3 squared, so pi r squared, times the height of my shape, which is now an 8. And that would give me an answer of 226.19 centimetres squared. And this one here I did do, 176.71 metres to the power 3. Okay, your last one's a wedge, and they do love the wedges as well. Hopefully you'll remember from your previous section how to get the surface area of the wedge. This is just a part of the circle. So basically we're going to use the formula for the surface area of a whole circle, but then times it by what fraction of the circle we've got. So the volume is going to be equal to pi times my radius, which here is 10, times, so pi times r squared, my bad. Take that off there. Oh, goodness. Right, so pi times my r squared would be my full circle. But I don't have a full circle. I've only got this sort of fraction of a circle going on here. If I had the full one, this whole thing would be coming out here. And so basically I'm timesing it by what fraction of the circle I've got, which is my 35 over my 360 degrees. That would give me the that sort of wedgie shaped face, if you like. And once I've got that, I'm going to times that answer by 6, which is the height. That was my uniform face, that first bit. If I was to slice, oopsies, let's try and get that bit neater. If I was to slice this shape through, you can see that wedge shape would remain. So then timesing by 6 puts me through the rest of that. So that would give me a final answer of 183.3 centimetres to the power of 3. The wedgie face, if you like, on the top, the answer for that was just 30.54, and that was in centimetres, and that's the surface area, so that would be squared. But the time you've times that by the third dimension, that brings you to the power of 3 at the end. Okay, and then we have our spheres. So a sphere, hopefully you remember that formula. The volume was 4 times pi times your radius to the power of 3, because it's a volume now, dividing by 3 to allow for the fact that it tapers. So here 4 times pi times my radius, which was 4 metres, to the power of 3, dividing that by 3. and that would give me a volume of 268.08 metres to the power 3. Your second shape is the same, except it's half of a sphere. So you've just got to remember to get your answer and then divide it in half. So again, your volume is going to be 4 times pi times your radius, which now was 2 to the power of 3, divided by 3. That would have given you a full sphere. You've only got half sphere, so if you get that answer and then divide it by 2, that would give you 16.755 metres to the power of 3. I should add at this point that, you know, if you're doing multiple choice questions, sometimes they'll present these things a little way. Instead of doing this divide by 2, I could have added the 2 on the bottom of the fraction line here, so I could have effectively been dividing by 6. That would be doing the same thing, but, you know, depending on what your maths is like and how confident you are, otherwise just find your first answer first and then divide by 2. It's the same thing. Now, the last bit we need to cover is capacity. So capacity is basically just turning your volume into a measure of how much liquid or gas your container can hold. So to calculate the capacity, you first always calculate your volume if it hasn't been given to you, and then you turn that to capacity. What you need to remember is that if you've measured in centimetres, centimetres cubed of course, then every centimetre cubed is 1 millilitre. So your measurement automatically is giving you the amount of millilitres you need. If you've got an answer that's a lot of millilitres, then it probably makes sense to divide that by 1,000 and turn it into litres, you know, or make it smaller again if needs be. If the question requires your answer in millilitres, then you're safest to convert all your measurements to centimetres first to work out your volume, and then away you go. If you've done your measurements in metres, then every 1 metre to the power of 3 is equal to 1,000 litres, or 1 kilolitre. So if you've measured your original object in metres, then your answer is basically in kilolitres, and timesing it by 1,000 will give you your answer in litres, which is usually making logical sense. So if they've got really extreme, then you might also get a megalitre. A megalitre is 1,000 kilolitres. Mega is usually in the millions, so hopefully that will help you to remember. And a kilolitre, of course, is 1,000 litres. So I have given you the little table there as well. So basically you're always timesing by 1,000 to move between megalitres, kilolitres, litres or millilitres. Okay, so let's quickly do these ones. So if I was doing that first object, first to get the volume, I would be, so I'm doing this one here, to first get the volume I'd be going 8 times 7 times 6.5. That's going to give me my volume, and that would give me an answer here of 364. That was in centimetres, so centimetres to the power of 3. Every centimetre is also every centimetre cubed is also a millilitre, so that would mean my answer is 364 millilitres. If I did the next shape, I've got so I'm doing this one here now. This one here is a cone, so my formula for the volume of a cone is pi times my radius squared. They've given me here the diameter, so don't forget you only need the radius, which is half of that. So pi times 5 squared, that's the circle on the top, timesing it by the depth, which is 8, would give me the volume. That's going to give me a volume of 209.4 centimetres to the power of 3. So again, each centimetre cubed is also millilitres, so that's 209.4 millilitres. It would probably make sense to round that to just 209 millilitres. Your last one is a cylinder, so the same sort of deal. To get the volume, you're going to go pi times your radius, which is 4. Oh, now we haven't got the height here, so pi r squared times the height. Now this was a trick one. Sorry, I got a little bit distracted by my dogs in the background. This one here, if we read the full question, they actually require you to work through the first 2 and then work out the height here. So I'm going to read you the question. So it says, consider the following 3 containers. Find the capacity of A and B, which is what we've done down here. Container A is filled with oil. The oil from A is then poured into container B until it's full, and then the remainder is poured into C. So basically, to work out C, we're going to use some algebra. We know that the volume of C would be equal to pi times your radius squared times your height, and then that would be equal to the volume, which I'll put on the left hand side. I'm going to move it over here again. We can calculate that volume because we know that basically we've taken that initial quantity of oil, the 364 millilitres. We've taken away the 209.4 millilitres that have been poured into the cone, and so what's going to be left will be the answer to that one. We know the pi, we know the radius was 4, so pi times 4 squared times my height. So that leaves me with the only unknown being my height. Now at this stage, if you're in a class pad calculator, you're pretty much finished. You can type this in. We know that's how we would calculate it. So you could type that in and then use that interactive advanced solve. Don't forget, if you don't use an x here, if you use h like we have here, then you need to overwrite the x in your class pad with a h. And then it will just solve it for you with no zero algebra required. If you're one of these stubborn people or the question requires you to do the algebra, then you want h. You're trying to solve for h. So you're going to get your h. I'm just going to do that subtraction first for that bracket. What have we got? 364. Take 209.4. That's going to give me 154.6 as my answer there. So when I rearrange this, the 154.6 is staying where it is. Sorry, I should just circle that. The h is staying where it is. And what I have to shift is the rest of this. And so basically I was timesing. So the opposite of timesing is dividing. So I would move that under there. And you'd wind up with an answer of 3.07 centimetres. This was in millilitres, but of course because the centimetres and the millilitres line up, you'd wind up with the final answer of that. And that would be you done. I might do the next one on another video.